Okay. Well, I'll just go over a question and then we can work on it together. And it's mostly on what you guys have been learning so far. And I'll type it up. All right. So this is the question. Platinum has a work function of 6.35 EVs. What is the longest wavelength of light in nanometers that will cause ejection of electrons? Okay, so with every question, what is the first thing that we always want to start off with, or what do we want to do?
We start with the given?
Yeah, we'll start with the given. And what are our givens in this case?
Our givens are 6.35 EV.
Okay. 6.35 EV. Let me write it down. So, yep, 6.35 EV. And what else do we know about the information here with just this question?
That is the longest wavelength of light, and how do you say NM?
And nanometers?
Nanometers, yeah.
Right. So yeah, they're asking you, so you're given this, right? And we want wavelength or the longest wavelength. And in what units do we want our wavelength? In meters or in nanometers?
Nanometers.
Nanometers, right. So nanometers, just to keep a note there. Okay, so from what you've learned so far, what equation involves energy and wavelength and all that stuff? I'll start it off. So E is equal to what?
Wouldn't be 1/2, and then I don't know if I'm wrong.
No, go ahead. 1/2.
1/2. Oh my goodness. And then it was, I don't know if it was, no, I think that's for kinetic energy. MB.
Yeah, you're right. That's for a different type of energy.
It's because everything is coming, even the word lambda that is, coming back to my head. So I don't know if you're gonna use that too. I don't know.
Lambda. Okay. So what do we know about lambda? Lambda is what?
The lambda is C equals, and then I don't know if it was H. Oh my goodness, I forgot. No, wait.
Fine.
Let me remember. I know it.
Okay.
Wouldn't have been E equals H and then C over I don't remember the symbol, but it was like,
you're in the right track.
It looks so weird. Yes, it looks so weird.
No, that's fine. So H times C over lambda, right?
So that's okay. So that's the thing.
Right, lambda. And it's the wavelength because it's wavy. That's how I like to think of it. Wavy, wavelength.
Mm-hmm.
Right.
Oh, and then it wouldn't be C equals lambda, which is, and then nude equals F. Was it FR?
There's a lot of equations, right?
Yeah, that's why I get so confused.
I understand, yeah. And all of them kind of do go hand in hand. But for this particular question, this is the one that we want to use.
Yes.
So here we know that H is what? H is a what?
Isn't it a height? No way.
Think of from SpongeBob. I don't know if you watch SpongeBob. Mr. Krabs is always in competition with who?
With plankton?
With plankton, right? So this is Planck's constant. Think about it that way. So remember,
Okay,
Planck's
so
constant is a constant, which is what? It's already a given number. And what is that number?
I don't know if it's 0, but no way.
Here, I'll start it off. 6 point.
6.35. No. Or we're talking about the Avogadro's number.
We're talking about Planck's constant, which is h, right?
Yeah.
So Planck's constant is a given number. It's kind of like mole. You know, Avogadro's number is 6.0.22, right? Times whatever and whatnot. That's a constant. It's constant throughout. The same thing with with Planck's constant, right? It has a number associated with it. So what is that number? Come on, you guys are all smart. You made it to 1B. You got this.
Does any other knows? Because I feel like I'm the only one.
Yeah, anyone else would like to participate?
I mean, even though you guys get it wrong, I mean, at least, you know, it's
Yeah,
nice to try.
Right. We're all learning.
I don't have it memorized, but I just found it in the notes.
Okay.
6.626 times 10 to the negative 34.
Times 10 to the negative. Yeah, good job, Michaela. And what are our units associated with this?
It's joules per second, or joules times second.
Right. Yeah. And we also know C is another constant. It's the speed of light. And what do we know that number to be? So I'll start you off. 2.988 times 10 to the 8
meters per second,
right? So H and C here are our constants. So then from there, because we want to find the wavelength, now we're just going to do a manipulation of this equation to get wavelength by itself. So in math, if you take the reciprocal side, you have to take the reciprocal of the other. So because our lambda is in our denominator, and that's what we want to find for, we want to do the reciprocal of both sides. So it'll be 1 over E is equal to lambda over H times C, right? So then from there, if we want to get lambda by itself, what do we have to do here?
Don't you have to divide it or cross it out?
So if we want H, or if we want lambda by itself, what do we have to do with these numbers or with these constants? So it's kind of like algebra, right? So we have here 10 over 2. If we want X by itself, what do we have to do with this 5?
Multiply both sides.
Right, multiply both sides by 5. So then here, what do we have to do with these constants?
Do the same process?
The same process, yeah. Good job, yeah. We just multiply both sides by the constants. So H, C, H and C. And then, yeah, they cross off. And then you're left with this equation, lambda, right, is equal to 8.
60. 60. Me dio 40, ¿verdad? 40 de... Necesito darle 60. Pero yo ya cambié el video, lo dejo nada más ver.
Right. So, and then from there, we just plug everything in, right? So we know that our energy,
Mi tía me dejó pobre.
6.35, right? We know that our H and our C are constants.
Profesor, sí está bien bonito.
But we also have to keep in mind that they give us this in the equation, right? So we want to convert that into joules. So then this is going to be another equation by itself. So we start with our given 6.35 eV, and we convert it to joules, and they're telling us that 1 is equal to 1.6 times 10 to the negative 19 joules. So when you plug that into your calculator, you get, let me plug it into the calculator. 1.6. And we get 1.1016 times 10 to the negative 18. And how many sig figs do we want for this equation?
Four.
Hey, we want, or so why would we need 4 for this one?
Oh, sorry. I was looking at the constants.
I see. So Alberto said 3. We want 3 sig figs because this is our work function. Our work function has a total of 3 sig figs. So then we convert this into 3 sig figs, 1.02 times 10 to the negative 18 joules. So then from there, we're just going to plug everything into the equation that we found earlier right here. So lambda, or our wavelength, is equal to h, which is our Planck's constant, 6.626 times 10 to the negative 34 joules per second. Let me take this out. Times the speed of light, which is 2.988 times 10 to the 8 meters per second, over our energy, right, which we converted into joules, and we found it to be 1.02 times 10 to the negative 18 joules. So then from there, after you plug it into your calculator, let me plug it in, we should get, so I got 1.95 times 10 to the negative 7 meters. So will this be our final answer?
You have to convert it to nanometers.
Right, we're gonna have to convert it to nanometers. So then it would be meters at the bottom, right? And then nanometers at the top. And we know that 1 meter is 10 to the 9 nanometers. And if you convert that, that would be equal to 195 nanometers. And then that would be our final answer for this question. Does anyone have any questions regarding this or anything about this?
I feel so good about the way I spent the last 2 days working so much, and I really want to just.
I don't think so, to be honest. I just know that I got lost.
Okay, where did you get lost?
Almost halfway.
Halfway, okay.
Yes. I understand the first part that we were working on,
Mhm.
but then when they went to, let me see. Let me check. Oh yeah, like the equations, it's gonna look like tipo garabato, and
No.
so yeah, that's what my mom says all the time. Se mira puro garabato.
I see.
Yes, but the last part I get, and the first part I get, but the middle part, where it has the equations. That's where I always get lost.
Okay, so the reason I do this, or before we plug anything in, I like to manipulate the equations. So then at the end, I just plug everything into the equation. So the original equation that we started off with was this one, right? Oh, was this one, right?
Yes.
And then from there, we're like, okay, we know we're going to use that equation, but we're going to have to find wavelength. And our wavelength is right here. And what you can do if you want to, and it really depends on the type of student you are, but either or works. You can plug in what you have already, because we have H, we have C, and we have E, right? And you can leave lambda by itself. So you can say, okay, our E is 6 point, what is it? 1.02 joules. 1.02 times 10 to the negative 34 joules times second, right? That's our E, is equal to, and then we plug in our constants, our H and our C. Just pretend there's the 6.626 here and then the 2.988 there over our lambda. So now this just becomes a regular like math equation where you just solve for X, but in this case, solve for lambda. So what I do, I manipulate the equation first and then plug in my numbers. But if whatever works with you, like if you can plug in the numbers and then solve it, both are correct. There's no wrong or right way.
Okay, I get you now.
Yeah. Okay. Any more questions? Yeah, so this is actually one of your questions from your Chem 101 when you started and when Dr. Henry gives you access to it. But this is one of those questions that are in there.
I'm working on that homework right now, actually.
Okay, yeah, if you guys have any questions, let me know and I can try to help.
So those constants are going to stay the same throughout the wavelength?
Right, those
Like
constants,
questions with
go ahead.
those constants are going to stay the same throughout the questions with wavelengths?
Right, so Planck's constant always stays the same. The same thing with the speed of light. The speed of light will always be that. And it's kind of like I was saying earlier about Avogadro's number. Remember, you know that Avogadro's number will always be what? 6.022 times, right? So it's going to be the same thing with Planck's and the speed of light. Yeah, you're right. So it's going to stay constant throughout.
Okay.
And then Mauricio, you said you wanted to do another question? Do you have like a question in particular that you want to do, or just another question in general? Okay, so here is the other one. So again, what are we given? What do we want? And what do we have to work with? So let's start off with what we're given. So what are we given here in this problem?
The frequency?
Right, the frequency. So we have that frequency is equal to what? The 8. Oh my god, yeah, 8.63 times 10 to the 8 hertz. So what is another thing that you learned during lecture? Hertz is the same thing as saying what?
1/2 seconds.
right? 1/seconds or second to the -1 power. And they're asking you, what is the energy of this photon? So we want to find energy. So given the information that given the information, what equation will we be using? Because they also give you the constant, right? H is equal to 6.626 times 10 to the -34 joules times second. So what equation can we use in order to find what we want to find?
So you use E equal to HV.
Right. We're going to use E is equal to HP. So then this just becomes another just plug in question, right? So we're just going to plug everything into our question, 6.626 times 10 to the -34 joules times second times our frequency, which should look like this. I'm really bad at drawing. 8.63 times 10 to the 8. And just so you guys can see what happens to the units, I'm just going to write 1/s instead of hertz, but it's the same thing. So then from there we have that, seconds cancel out and we're left with what we want, our joules. So our units really help us out, kind of see like if we're on the right path. So in this case we are, because we have joules. So when you plug that into the calculator, you get
Hey, Jess. Can you hear
Hey,
me?
Dr. Henry. Yeah, I'm just going over a question right now.
Perfect. I knew you were going to
Yeah.
do that, see? And, it wasn't that I forgot about class or anything like that.
Right. No, yeah. You never forget, Dr. Henry.
Never.
So how many sig figs do we want for our final answer for this one? We want 3 sig figs. So our final answer would be 5.72, 5.72 times 10 to the -25 joules. All right, Dr. Henry, it's all yours now. We went over 2 questions. Any questions on this one, you guys?
No, that one I got it better than the first one.
Okay, sounds good.
Oh, I have a question over the 1/s.
Mm-hmm.
Why do you put that there?
So we learned in lecture that hertz, right, is the same thing as saying 1/s or 1/seconds or seconds to the exponent of -1. And the reason that I put it right here is so you guys can see how the units cancel off, right? And you're left with what you want, joules, your energy. So that's why it's always important to keep track of your units so you can see if you're going the right direction or not with the question. Did that answer your question?
Yes, and then the V, it just means frequency.
Oh, yeah, right here. No, this was supposed to be a check mark. Sorry, but this is E.
No, so HV.
Right, the frequency. I don't know how to draw. I'm so bad at drawing. But yeah, something like that. Yeah.
Okay.
Yeah, and then H is your constant, E is your energy, and then yeah, this one should be your frequency.
Okay.
All right. I think I'll let it. I'll take Dr. Henry. I think, or is he talking on the phone? He's talking on the phone. Yeah, and I actually posted my link on the syllabus. So when you guys click, because I have tutoring from 6 to 9 at night, but if you click on the link on Tuesdays and Thursdays, like it'll take you directly to my Zoom meeting.
Nice.
So let me stop sharing, and then once Dr. Henry is done, hopefully he'll start.
Can you guys see my slides?
Yes.
Okay,
Yeah.
so if we run out of energy, you know it's because I didn't charge my battery completely. Okay, so because I'm outside at Lemoore. Okay, so Bohr basically, one of the things that Bohr had done during his modeling of the hydrogen atom was he recognized that there was quantization of energy, right? That was one of the most important contributions that he had provided. And so, but he had also noticed that when he did his modeling, it worked perfectly for the hydrogen atom, but it didn't work for any of the other atoms, right? Why do you think that it didn't work for any of the other atoms like helium or lithium or calcium?
Is it because they have
Okay, hold on. We lost the student. Give me a second.
Oh my God, that was so funny. He was just waving. I was like, oh, hallelujah.
Yeah.
Amen, sister. I mean, brother.
Oh gosh. You know how this feels like one of those like Facebook lives?
That's exactly what I was thinking.
Yeah.
Dr. Henry's
It feels
Instagram
so
living his
weird.
lecture.
Oh my gosh.
To be honest, this is my first class and where my rooster is not getting into that class. Because he's always trying to see with who I'm talking on the phone. So he puts his head just like that, and then he tries to stare to like, take classes as well.
An
Even this
educated
one's too
rooster.
boring for him.
Hi, Cameron. Is that you? Oh, that's the other tutor, you guys.
Hi, I'm Cameron.
Hi.
Jessica. How is everyone doing?
Good.
If anyone ever has any questions, you're always free to ask me or email me.
Are you out? Cameron, can you hear me?
Yes, I could hear you.
Are you in Lemoore?
Yeah.
Dr. Henry? You're helping him with the kids?
Yeah.
Okay.
It's the only day I can make it.
So.
So.
Yeah, I think Dr. Henry forgot about the class. But, it's better late than never.
Yeah, that's true.
Oh, actually, I just remembered. Do you guys know how we're doing the labs today? My sister told me it's through that. I don't know what it's called, but like that virtual lab thing.
Yeah, I think you guys are going to do simulations because not everyone has gotten their lab yet.
Right.
And I think Dr. Henry will email you guys more information on that. But for the time being, it's the simulation.
Okay. Because I noticed that there wasn't any like labs to print out, so I just want to make sure I wasn't missing them or something.
Right, yeah.
Did you unmute yourself? Did you introduce yourself? Yeah. Okay, sorry about that, guys. Okay, so this will be real quick. I know we only have like 15 minutes left, right? And it's getting late. Okay, so real quick. So Bohr basically said, well, his model for the hydrogen atom basically worked great. So that concept of having, a ground state energy and being able to excite it to the other states, it all worked out perfect. So what do you guys think? Why do you think it didn't work for all of the other atoms?
Is it because they have neutrons and hydrogen doesn't?
Because they have what?
Neutrons.
Neutrons. So yes, that is partially part of the reason. It has to do with this, the fact that there are neutrons, but there's also something else. One other thing.
Is it because they have more than one electron?
Yes, it is because it has more than one electron. Okay, Jessica, you're gonna get spanked. Okay, so how many of you guys have relationships or have been in a relationship?
Mm-hmm.
Mm-hmm. Yeah,
Mm-hmm.
good.
Yep.
Everybody's been in relationships. Perfect. Okay, so if you think about electrons, right? So what happens when you have an electron? Two electrons together. Electrons. Sorry. You bring two electrons together. What happens?
They don't like connect or attract. They don't attract, the opposite.
They
right?
don't attract. So then what do they do? If they're
They
not
repel?
attracting, they're what?
Repelling each other?
They're repelling, exactly. So they're repelling, right? And so they're repelling from each other, right? So there's the electron-electron type of interaction that goes on, right? So you have to account for those electron-electron interactions. And Bohr's model doesn't account for that. It only accounts for the electrons, and that's it. Nor does it account for neutrons. It accounts for the electrons and the protons being in the middle. That's basically, okay? So, so in this case, because of that, it doesn't take into account all the other things. So kind of like, you know, if you guys have been in relationships, right? So if you and your partner who you were in a relationship or who you're currently in a relationship or who you're currently married to or whatever, you know, you guys have that interaction and stuff, kind of like that, the protons and electrons. However, you also have to interact with your in-laws, right? And he has to interact with your in-laws. Is that true? Yeah, no, maybe.
I mean, have to is a strong word.
You said have to is a strong word. Okay, so similar to that, because of that, you have these other characters that are playing a part in that process. And that also kind of sets up the tone for quantum. So Bohr, even though that Bohr kind of failed in the concept of explaining that full model, he is still considered the father of quantum mechanics because of the fact that he recognized that it was quantization. And then also the fact that there's a possibility that wave particle theory going on, or duality going on. Come on. Okay, so Bohr basically got his Nobel Prize. He's all happy. He's good to go. And he also recognized the different energy levels that we're talking about. And he also found out that as you get further and further away from the nucleus, the energy also increases. Okay, so it takes more and more energy to kind of keep those electrons in those states if necessary. You have to put them up that way. Okay, and that's going to be kind of important for us kind of understanding why things do what they do. Okay. No. Okay, so there are other people who have also contributed to that process, right? And so one thing that kind of Bohr and quantum kind of plays a part in is saying that, you know, because we have the wave particle aspect of things, it doesn't behave the way that we would think of just a particle or a wave is going to behave in terms of a macroscopic way. So it behaves sort of differently. And we're looking at something that's small compared to something that's big. And so the wave particle duality is definitely what happens in the case of those smaller particles, in the case of the electron, where, you know, when we look at big things, we only think about just the wave, or we just think about the particle. We don't think about it having both dualities. Okay, so this is just basically the spectrum, right? To kind of remind you what the visible light spectrum kind of looks like. And this here is just, you know, kind of a wave going on in water. And you can kind of see that interference pattern. And so like as the wave, if it's destructive, it's going to cancel each other out. And so then you're going to see it stopping. If it's constructive, then it's going to continue to expand and continue to make bigger, bigger ripples. Okay, let's see. Okay, so we are gonna stop here, even though I wanted to talk about this. And I'm gonna meet with you guys for about 30 minutes on Wednesday. Although, and it's gonna be the last 30 minutes of class. So at 6 o'clock-ish to kind of go over this part. So you'll be at the same stage as the other. So on Wednesday, the beginning part, I actually have a meeting. So I'll be at a meeting at the beginning part. And then, so I'll meet with you guys the last 30 minutes of class to kind of go over what you guys are gonna kind of get you caught up with everything else. But Jessica is gonna be there to help you out with something. So you guys are gonna be working as a group. So on your group project. So we're gonna reintroduce your group project on Wednesday. And Jessica's gonna kind of lead that. So you guys can have that time, that hour to basically talk about your group project. So you gotta give me 30 minutes of that last part. Is that cool?
Yes, I also have a question, Dr. Henry, about
Yes,
Chem
ma'am.
101.
Yes, ma'am.
So you see, last time I went to check, you know, to try to log in and Chem 101, but it's asking me a code. For example, it says
that's because you need to go through Canvas. If you go outside of Canvas, it's gonna ask you for a code.
Yeah, it's because it's asking me to put a different class.
That's because you need to go through Canvas. So you want to go through Canvas to log.
Okay, so I just go to Canvas and find Chem 101 right there, the link. And
yes, it should be under getting started.
oh, okay, yeah, thank you.
Okay, no problem. Any other questions? Okay, well, sorry that it was a little confusion. My fault again. I too many places at once, you know. And there's only one of me, so sorry about that. And so I will see you guys on Wednesday. Okay.
All right.
Okay. And does everybody got their lab right? Oh, wait. There's one other thing before I let you go. One more thing. So, you want to write this down? Maybe I should write it down. Okay. So you want to check to see if you guys have copper, a copper strip. You should have 14 alligator clips. You should have black cardstock paper. And filter paper. If you're missing any of those things, can you please let me know so that we can get it to you? Because I know that some of the kits, we were short on it, and the supplies didn't come in today, or actually came in yesterday. So.
Oh, okay. So the lab is on campus, right?
The lab?
Mm-hmm.
Yes, your lab is going to be on campus. But I need to know that you guys, I'm talking about your kits, the kits that you guys got. Check to see if you guys are missing any of these items.
Are we supposed to do a lab today?
No, you're not doing a lab today.
Okay.
And you're not doing a lab on Wednesday. You're going to do your first lab next week. We're going to push it back to next week. Okay?
Yeah, next week on Wednesday, right? Because on Monday.
Oh, yes. Damn it. Okay, on Monday you have a holiday. Don't tell him that. I wasn't going to tell him.
I'm sorry. Oh my gosh. I'm sorry.
You messed up, Jessica. No, I'm joking. Yes, thank you, Jessica, for reminding me. Next Monday you have a holiday. It's the day that I'm recovering from my hangover. That's what it is.
Were you really gonna make them work during the holiday, Dr. Henry?
No, I wasn't. Of course I wasn't. Like again, my birthday's on the 14th. Do you think I'm gonna make you guys work at the 15th? Because I'm gonna be hungover from celebrating my birthday. You know, I'm just turning 21. So
Well, my birthday was yesterday, and you're making me work today, so
are you a little hungover?
no, I can't go anywhere. COVID.
Yeah. Well, see, I'll be drinking all alone by myself, but you know, still gonna be hungover.
Yeah.
Oh my God.
That's
So
the
your
solution.
birthday is on February 14, Valentine's
That's right.
Day?
That's
Oh,
right. I'm a
that's
love
so
child.
nice.
Yep. Okay. So you guys are clear what I asked? We're good?
Mhm.
Yes.
Yeah.
All good.
Okay. So let me know and then I'll try to get those to you and I'll hand deliver them because since we're so behind and there's only a little bit of you guys compared to my other class where I have billions of people. So
Sounds good.
okay, Mauricio. So about please help me with your love story. Okay, so Mauricio, what you need to do about access to Chem 101. So you need to go to Canvas. It should be under modules and it should be under getting started. Should be. Is it not there?
No, you can get into it from there. The first homework is set due for this Friday as well.
Yeah, it's going to change. I'm going to give you guys some more time because
Oh,
I had hoped to go over the whole chapter, but I forgot that I have a full day meeting on Wednesday. Okay, so I'm going to extend it a little bit. Okay.
mhm. Wow, he didn't even say goodbye.
Well, he just yeah.
He just left. His phone probably died, I bet.
Facebook Live, I'm telling you. All right. Well, I guess this is it for tonight. But yeah, if you any of you guys have any questions, feel free to email me or Dr. Henry.
I'm probably gonna stop by tomorrow just to work on homework.
Okay, sounds good. Yeah. I'll wait for you. I was lonely last time. No one
I
showed
didn't
up.
have any homework.
All right.
It's like the one song that goes lonely. That one.
Exactly like that. Yeah. All right, you guys. Well, enjoy the rest of your night. And good luck with everything else.
Thank you. And you too.
Thank you.
No, night night.
Bye.
Bye.